In the last video about scientific notation, we learned how to convert standard form number to scientific notation based on the fact that scientific notation has two parts. One is going to be the coefficient that has to be greater than 1 or equal to 1 but less than 10, and time to the exponent part with the base of 10 to a specific power. Okay? In this video, we are going to look at more example where this is hidden in the problem. For example, and of course we are going to use the acronym LARS again. The left. LAR is for moving decimal to the left, you add to the exponent. And if you are moving the decimal to the right, you subtract from the exponent. So you'll notice the practice problem, it doesn't have 10 to the power of something. But there's one thing that you need to know about exponent. That is, any number to the 0 is equal to 1. So we can assume that if we have 10 to the 0 is also equal to 1. And anything multiplied to 1 is equal to itself. And 5,000 times 1 is equal to 5,000. So let's go back and use the acronym LARS again. Our decimal is going to be right here, and we are going to make the exponent part greater than 1 or equal to 1, but less than 10. So we move this way, 1, 2, 3. We are decreasing the values of the coefficient part by 3, so minus 3. So we do the opposite to balance it out. 1 go up, we need to do the opposite, so this way it stays the same. And therefore, we add the exponent 0 plus 3, that gives you 10 to the 3. 5.000 times 10 to the third. Let's try another one. Again, no exponents is given to us. So 10.0 times 10 to the 0. Moving this place to make it less than 10. So you decrease the values by one place. You do the opposite, you add 1. So 1.00 times 10 to the 1. Let's try this one again. No exponent, so 500.05 times 10 to the 0. Again, if there's no exponent, you get to assume that is times 10 to the 0 power. So anything to the 0 is equal to 1. So move 1, 2, because 500 is greater than 10. So there you go. Now moving 2, that decreases the value by minus 2. You do the opposite, you add 2 to it. So you have 5.0005 times 10 to the second power. Now let's try some more problem. We have the decimal right there. In this case, the number is smaller than 1. So again, assume that it's still times 10 to the 0 power. So what we have here, we're moving this way, 1, 2, 3, 4. So we actually increase the values by 4 places. And we do the opposite of it, which is minus 4. So 0 minus 4 gives you negative 4. So our answer is 5 times 10 to the minus 4. And again, in this example, we don't have the exponent part. So we can assume that is multiplied to times 10 to the 0 power. So this is smaller than 1, so we had to move the decimal this place by 2 times. And that gave us 1.0. But we just decreased this value by 2 places. So we had to do the opposite. We add 2 places. 0 plus 2, that gave you 10 to the second power. So we can say 1.0 times 10 to the second. One last one in this example. We have 0.00505. Of course, it's going to be times to the 10 to the 0. So 0.0505 times 10 to the 0. This is a lot smaller than 1, so we had to move the decimal this place. 1, 2, 3. Oh, there you go, 3 places. So we now just increase the values of the coefficient by 3 places. So we can do the opposite again, which is minus 3 to the exponent. So 5.05 times 10 to the negative 3. And of course, I didn't write down the unit and the chemical because it takes too much time. Now, we are going to do the opposite. That is, we are going to change a number like this, look like a scientific notation. That is, it has a coefficient and an exponent, we are going to change back to pure standard form number. That is, we are going to write down all the digits in that number. So, of course, we are going to do the opposite. Last time, we moved the decimal first, then we changed the exponent. In this case, we're going to do the opposite, which we're going to change the exponent, and then we're going to move the decimal. But what do we change the exponent to? Because we want to get rid of the exponent part, the only way we can do is change the exponent to the power of 0. Because anything to the 0 equal to 1. So you want to make your exponent equal to 0 because of 10 to the 0 equal to the power of 1. You either add to the exponent or you subtract. Let's do one example. And the concept of large is still applied. Left, you add, right, you subtract. But in this case, you're going to look at add or subtract first. Let's look at an example. Here I have 5,000 times 10 to the negative 5. We're there, changing the exponent first. And then we're going to move the decimal. In this case, negative 5. How would negative 5 become 0? We are going to add 5 to it. So we add 5. Because negative 5 plus 5 equals to 0. Now, the addition part is the A part, right? So when we do A for adding, what happened to the direction of the decimal, which is to the left? So that's what we're going to do. Where is the decimal in this case? It is right here. And we are going to move to the left. By how many places? By the places based on the number you just add. In this case, 5 places. 1, 2, 3, 4, and 5. And there you go. We can rewrite this in standard form of 0.05000. And that is our answer in standard form number. Let's try another one. Here I have 1 times 10 to the negative 3 grams of calcium oxide, or CaO. So this is negative. One way we can make a negative 3 become 0 is adding 3 to it. So when we add 3, again we add, we are going to move to the left. The same thing, the concept of large still apply. So we move how many places? 3 places, because we add 3. So we move 3 places to the left. Here's a decimal right there. 1, 2, 3. So we have our answer as 0.001. 500.05 times 10 to the 0. This is already to the 0, so our answer just be like this. Because this is 1. Let's do some more examples down here. Again, the concept of large is still applied. In this example, we have 100 times 10 to the third grams of NaCl. Notice how the exponent is positive. So how can I make plus 3 become 0? Of course, I'm going to minus 3, and that will give us 0. And when we minus, that is subtraction. So which is the S in large? And what direction is that? That is the right. So subtract, going to the right. What does that mean? Here's the decimal place. You move to the right. But how many places? Of course, 3 places. 1, 2, 3. So our answer is 1, 0, 0, and 3 more places. And that is how it works. If we were to test this with our calculator, if I type in 100 times 10 to the third, that will give us that number right there. You see it? Beautiful. Okay. And if we go up here and test with this number, we have 5,000 times 10 to the negative 5. And there you go. Give us 0.05. Beautiful, isn't it? Let's try another one. I have 10.0 times 10 to the second. Again, this is a positive 2, so we minus 2. That gives us 0. So we have to move to the right because minus subtraction. So to the right 2 places. 1, 2. So we have 1, 0, 0, 0. And that is our answer. Let's look at the other one. So we have 0.5 times 10 to the 0. And of course this is easy because 10 to the 0 is equal to 1. So the answer is just 0.05. And that is how you change a number in a format very similar to scientific notation or scientific notation itself to a standard form number that has all the digits in it.